Yeah, absolutely. All right, we have a light bulb is located along a principal axis of concave diverging lenses shown on the figure. The bulb has a height of 9 centimeters. So we know we're going to get a negative focal length because it's a diverging lens. So we're going to have the focal length should be negative for that, the first one. And then the resulting image formed by the lens is virtual, which means since it's virtual, it's going to have a negative image distance as well, virtual. So we're going to use hi, ho, si, so. And we're just going to write down what we've got here. So we've got the height of the actual object is 9 centimeters. The location, SO, is going to be 30 centimeters in front of the lens. And then the height final is equal to 3 centimeters. And it is a virtual thing, so the SI is going to be a negative answer. So the one thing about this equation is it only really gives us absolute value. So we're going to have to decide based on the fact that it says it's virtual that our SI is negative. So we have SI is going to equal HI times SO over HO, and I have 3 times 30 divided by 9, and it's all centimeters, so they're going to cancel out to be centimeters, and it will be 10 centimeters, but it will be negative. So I'm going to do 1 over F is equal to 1 over S naught plus 1 over SI. This is the thin lens equation, and I'm just going to solve for F. So I have 1 over F is equal to 1 over 30 plus 1 over negative 10. The common denominator here would be 30. So it's going to be 1 and then negative 3 there. So I get negative 2 over 30, and that will give me, that's 1 over F. So that means that F is equal to negative 15, which is the answer that we see here. When a candle is located distance DC along the principal axis of a converging lens, an image is formed a distance DI from the lens. The graph shows a reciprocal 1 over DI of the image distance as a function of 1 over DC of the candle distance. What feature of the graph is equal to the focal length of the lens? So again, we have 1 over F is equal to 1 over S naught plus 1 over SI. In this situation, we use D's, so we have 1 over F is equal to 1 over DI plus 1 over DC. DC is the distance of the candle. That's actually the object distance. So I'm just going to go ahead and solve this for 1 over DI, and that's going to give me negative 1 over DC plus 1 over F. And this is going to be then my y-intercept, the axis intercept of either graph axis. I think that actually would work. If we did it the other way, it would be 1 over DC is equal to 1 over DI plus 1 over F. So it should actually work, the axis intercept. Okay, wait, hold on. That's which would equal the focal length of the lens. Okay, that's going to equal 1 over F. So the reciprocal should do that, and that's D. That's the right answer. I'm sorry, I almost selected C, but that would be 1 over F, which I feel like that makes sense. Okay. A pencil of height HP is located distance dP from the concave lens as shown in the figure. And the lens, which has a focal length of negative 1/2 of the image distance, so because it's this, so it's going to be right here at 1/2 dP, forms an image that results in magnification M. If the pencil is then replaced with a shorter one, the same location, what is the object's resulting magnification? Okay. So we need to figure out hi, ho. This is equal to our magnification. So is psi so. Psi so is also equal to the magnification. So in this situation, when we do it at the current spot, when it's located here, we get this. So we know that hi ho needs to be equal to M. If we have 1/3 at the same location, what would be the resulting magnification? Ugh, this is an annoying one, I feel like. So we're gonna have to do some work. I'm gonna. Oh my goodness. Sorry, I'm also teaching a class at the same time, so that is slightly distracting me. And they're playing music now. Okay, so since we replace it with a shorter one, okay, the image distance and the object distance are the same, so it's still going to have the same magnification. That is the answer here. Okay, so I was thinking it was a little easier than that, but because it is hi-ho and SISO, because that's true, the image, even though we replace it with a shorter one, the image distance and the object distance do not change, so it's just M. Awesome, got it. All right, an object is located to the left of the concave lens as shown in the figure. The dots in the figure are located at the focal points and are each a distance f from the lens. Which of the following is a correct ray diagram for the principle? Okay, so if I was going to do these, my first ray would come from here and go that way. The second one would be trying to go towards this, but it can't, so it would go that way. And the third one, oops, I did a terrible job. The third one would go right through the center. So those would be my 3 rays that I would draw. When I'm looking at this one almost looks correct to me, but I don't actually draw a ray through this one at all. And if I were to, just for the record, and you can go ahead and check me on this, I would draw it through here. And when I got here, it would still divert away. Like, that didn't come out right. That's only because it like connected its own line. It would still divert away because it diverts. All of these would divert. They would never meet on this side at all. And they would all meet at the same point over on the other side. So this one cannot be correct. C looks exactly like, I'm gonna do purple, this one that I drew. The one's trying to go through the focal point, but it can't, so it diverts. So I think it's probably C, but let's just check. Well, this one completely looks wrong, and as does this one. So C is the correct answer, and hey, we got it right. Nice job. Thanks for watching.